Hello boys and girls, this is Mr. Giomini here to help you out with two questions that we struggle with as a whole on the pretest. So taking a look, and what I'm going to do first today, I'm going to actually do something a little different. I'm going to set the timer. I'm going to time myself to see how long it takes me to solve these problems, because as we've been talking about in the one class and a couple others, these 2-point questions should take us 5 minutes, or anywhere between probably 5 to 10 minutes to do, depending on our skill set. So I'm going to kind of set the timer and see how long this problem takes me to do. I'm going to go back here, set up my timer, and I'll just set it. Let's see here. I actually want to set this as, there we go. I'm going to bump that up to, let's see how long. I just give myself 10 minutes. Okay, so there's my clock. Okay, so use my point and say method. State one property that squares and rhombuses share. Then state one property that one of these shapes has, but the other shape does not necessarily have. Notice I'm using the same gridded paper that you'd be able to respond to on your OAA. So let me take my highlighter out. Actually, I'm going to use just underlining since you guys can't really highlight on the test. It says state, so it means tell. State one property that squares and rhombuses share, so that they both have in common. Then state one property that one of these shapes has, but the other shape does not. Okay, I'm going to go with, so I have to do one here. So this is definitely a two-step problem. What I'm going to do first, I'm going to actually draw a square for myself. There's my square. Now I'll draw a rhombus. There's my rhombus. Okay, now that I have them drawn, I could definitely see one thing they both have in common is they have 4 sides. So I'm going to write over here, same. Because if they have something in common, that means they both have, it's the same for both. Because when I have this type of paper, I don't necessarily have it divided into sections for me like we've been providing for you. So I'm going to just divide it myself. So both a square and rhombus have 4 congruent sides. Congruent means same measurement. So both of these have 4 sides. 1, 2, 3, 4. 1, 2, 3, 4. And this side on a square is congruent to this side, is congruent to this side, is congruent to this side. I'll even put marks. That side is congruent to this side, is congruent to this side, congruent to this side, congruent to this side. In a rhombus, this side is congruent to this side, congruent to this side, congruent to this side, congruent to this side. Okay. Now, okay, so let me go here. State one property that squares and rhombuses share. Both a square and rhombus have 4 congruent sides. Okay, that's one they share. So I'm done with number 1. I'll put a little check next to it. Now I have to do part 2. Part 2. Then state one property that one of these shapes has, but the other does not necessarily have. So now I'm looking not for the same, but I'm looking for a difference. Okay. Let me take a look back at these shapes. I know a square has 4 right angles. Those are all right angles. They all measure. They're classified as right angles. Their measurement is 90 degrees. So each one of those, where these angles are formed, where the two rays meet at this vertex here, it gives me 90 degrees. If I look at this angle and this angle look to be obtuse. This angle and this angle look to be acute. Though that's definitely different. A rhombus has 2 obtuse and 2 acute, while a square has 4 right angles. So, come down here. My difference. a square has 4 right angles a rhombus has 2 acute angles and 2 obtuse. Period. Okay. I've already checked off number 1, so I know we're good, and I reread that. Number 2. Then state one property that one of these shapes has, but the other shape does not necessarily have. Difference. A square has 4 right angles. A rhombus has 2 acute angles and 2 obtuse. I think I've sufficiently answered question number 2. If I hit stop on my clock right now, I've noticed that that question took me 5 minutes and 13 seconds to answer effectively. Okay, let's take a look at question number 5, which has to do with similar triangles. Once again, this would be considered a multiple choice. Multiple choice questions are supposed to take me about 2 minutes to answer. So I'm going to set my timer again. There's my clock. I said OK. Precision down there. Okay, let me read it here. Triangle KLM is a scalene acute triangle. Circle this triangle similar to triangle KLM. So I am focusing in on triangle KLM. Well, which one is KLM? This is WXY. Nope. This is WX. No. W. Oh, here's. Okay, so I'm looking at this triangle right here. This is where my attention is going to be. It's a scalene acute triangle. So that means the triangle I'm looking for also must be a scalene and acute. Well, these all seem to be scalene, meaning they all have 3 different side lengths, and they all have to have 3 different side lengths, and they all have to be acute angles. So I know that now circle this triangle similar to triangle KLM. Similar meaning like, the same as, or similar. They must be alike in some way, not necessarily the same, but alike. Now it says here it must be this is going to be a scalene acute triangle. So then the triangle that's similar must also be a scalene. Now I can automatically eliminate this one because this has 2 sides that are the same. That would be an isosceles triangle. So I know it's not this one. Okay, similar. This goes 2, 4, 5. One side's 2. One side's 4. Side KL is 4, and side ML is 5. Okay. Now I see that this has a 2. This has a 5. This has a 6. Well, this side stayed the same. This side increased by 1. This side increased by 1. Well, it's similar, but because these still stayed the same, that makes it too same. So I'm not going to do that. Too much alike. I go here. This side increased by 1. This side increased by 1. This side increased by 1. Okay. That so it makes sense, I guess. If I go here, now I have this is increased by 2. This is increased by 2. This is increased by 2. So it's similar because the dimensions are the same. I'm just doubling each one. So now I'm thinking here. So why would I go? Okay, so this one, every side increases by 1. This side, this doubles. So if I'm just adding one here, or I like this one here because I'm doubling each side. So I am going to go with this one because it is similar in that I am just doubling it. So the relationship is I have a 1 to 2 relationship. This is my scale model of 1. When I double it, that's my scale model of 2. Correct answer here is triangle WXY, where the sides are 4, 8, and 10. If I pull it up, that question took me over 2 minutes. The answer took me actually 3 minutes and 20 seconds. That's okay. I'm looking for the right answer, not the fastest answer. Hope this helps. Take care.